everyone and very good morning. I hope आप सभी अच्छे हो and सबकी एनर्जी हाई है and nobody is worried क्योंकि वरी होने की कोई जरूरत है नहीं. All you have to do is to practice. ठीक है. सभी लोग अपना स्पिरिट हाई रखो and keep on practicing until the day of exam, but by taking proper rest and care of yourself. That is very important क्योंकि to perform the maximum you have to be at the best of your health, right? So taking care of yourself should be your priority. Even reading should lie on the second in your priority list. So let's start. Wave optics mein first I will take you through formulas. So basically two things ka diagram with formula which should be clear about. That is, one is your YDSC experiment. ठीक है. And another is your diffraction portion. ठीक है. So in YDSC experiment we study about interference of waves, right? So if we have two waves, let's say one wave is this A sine omega t, and another wave is this A sine omega t plus phi. What you will talk about its phase difference. So phase of the first wave is what is omega t, and phase of another wave is omega t plus phi. So phase difference is here nothing but phi. Okay. And if we are going to interfere these two waves, y1 plus y2, what we are going to get? We will be getting 2a cos square phi by 2. This is the amplitude we are going to get of y1 plus y2 ka amplitude. Its amplitude will be equal to 2a cos square phi by 2. And let's say phase difference is 0, then amplitude will be simply a plus a, that is 2a. And depending on whatever is the value of phi, you will be getting the amplitude of resultant wave. Okay? And this formula is true only when amplitude of both the interfering wave is same. Then remember this thing in your mind. Now, what about the intensity? You already know intensity is directly proportional to amplitude ka square. So let's say first wave has a intensity of I naught. So definitely I naught is equal to some constant k into a ka square. Similarly, second wave will have intensity I naught. What will be the net intensity? If you calculate net intensity, then that will be what? Proportional to amplitude, resultant amplitude ka square. So when you will do the square here, you will get 4a square cos sorry, यहाँ पे मैंने cos square लिखा है. Sorry. This is 2a cos phi by 2. Okay. I'm really sorry. This is 2a cos phi by 2. So if you are going to do the squaring, 4a square cos square phi by 2. And 4a square को आप क्या लिख सकते हो? 4i naught, because a square is directly proportional to I naught. So intensity of resultant wave can be written as k into amplitude of resultant wave का square. So 4i naught cos square phi by 2. Done it? So if the phase difference is 0, then maximum intensity will be 4i naught. So I net को आप कैसे लिखते हो? 4i naught cos square phi by 2, where I naught is what? I naught is the intensity of first wave, and what is again I naught is also the intensity of second wave. So if two waves has an intensity of I naught and I naught, then for maximum interference, that is constructive interference, that is when phi is 0, how much intensity we get? 4i naught. And depending on different phase differences, we will be getting different value of intensity. Okay. Now the question is, what if two waves are not having the same amplitude? Let's say first wave has an amplitude of a1 sine omega t, and second wave has a amplitude of a2 cos. Sorry, let's write in the term of same function so that we can compare the phase. Whenever you have to compare the phase of two waves, always remember both waves should be the function of sine, okay, or cos. But one with sine, another with cos, then you cannot compare their phase. First, you need to convert either sine to cos to make both the waves function of cos, or you need to convert cos to sine so that make both the functions function of sine. Okay. So whenever you compare phase, this sine here also this should be sine omega t plus phi. नाउ व्हाट विल बी द रिजल्टेंट एम्पलीट्यूड. अब आप एम्पलीट्यूड कैसे लिखोगे? सो सिंपल है, यूज द वेक्टर मेथड. आई विल से, so these two y1 and y2 are vectors having phase difference phi. So this is a1 vector and this is a2 vector. I mean, this is y1 vector having amplitude a1. This is y2 vector having amplitude a2. And these two waves has a phase or vectors has a phase angle of phi. So a net आपका कितना होगा बताओ? ये होगा a1 square plus a2 square plus 2a1 a2 cos phi. So same thing I am going to replicate here. ये सारी ये सारे फॉर्मूलेज विद कॉन्सेप्ट शुड बी इन योर माइंड, क्योंकि तुम लोगों का क्वेश्चन बेसिकली फॉर्मूला बेस्ड है. सो यू शुड बी हैविंग अ गुड होल्ड ऑफ वट एवर फॉर्मूलाज आर देयर इन दिस टॉपिक. सो a1 स्क्वायर प्लस a2 स्क्वायर प्लस 2a1 a2 cos phi. ठीक है, इट इज दिस हियर. डन है. अब अगर आप देखते हो फर्स्ट वेव का मैं इंटेंसिटी की बात करूं, तो I1 विल बी डायरेक्टली प्रोपोर्शनल टू A1 का स्क्वायर, और I1 को मैं क्या बोलूंगी? के A1 का स्क्वायर. सिमिलरली I2 विल बी डायरेक्टली प्रोपोर्शनल टू A2 का स्क्वायर, एंड हेंस I2 को मैं क्या लिखने वाली हूँ? के A2 का स्क्वायर. के इज प्रोपोर्शनैलिटी कांस्टेंट. सो इंटेंसिटी ऑफ नेट वेव्स को आप क्या लिखोगे? के इंटू ए का स्क्वायर. सो यहाँ से अगर स्क्वायर करते हो, a1 स्क्वायर प्लस a2 स्क्वायर प्लस 2a1 a2 cos फाइव. ये फॉर्मूला सबने पढ़ा होगा. के a1 स्क्वायर को i1 लिख सकते हो, के a2 स्क्वायर को i2 लिख सकते हो. ये क्या हो जाएगा? a1 को क्या लिख सकते हो आप? यहाँ से देखो, a1 को लिख सकते हैं रूट अंडर i1, रूट अंडर i1 बाई k1, एंड a2 कैन बी रिटन एज रूट अंडर i2 बाई k2 इंटू cos फाइव. ठीक है. और यहाँ से के था तो ये रूट अंडर केवन, रूट अंडर सॉरी केवन ही होगा. ये सारे कट जाएंगे, है ना, क्योंकि दिस के को इफ यू विल मल्टीप्लाई इनसाइड यू विल गेट 2a1 a2 बाई के, है ना. सो इसको लिख सकते हैं 2a1 बाई रूट के, एंड इसको लिख सकते हैं a2 बाई रूट के. डन है. a1 बाई रूट के किसके बराबर होगा? तुम्हारा i1. डन है. सो दैट इज सॉरी रूट अंडर i1, दैट इज व्हाट आई हैव रिटन. इसको अगर आप सॉल्व करोगे तो ऐसा कुछ आया. अगर मैक्सिमम निकालना है, आई नेट मैक्स, मैक्सिमम कब होगा? व्हेन फाई इज 0. सो इन दैट केस इट विल बिकम i1 प्लस i2 प्लस 2 रूट i1 रूट i2. ठीक है, इसको हम कैसे लिख सकते हैं? रूट i1 प्लस रूट i2 का स्क्वायर. So this is inet max. Inet minimum you will get when you will be getting it minimum when phi is what? 180 degree. So for that case it will be sorry, it will be i1 plus i2, i1 plus i2 minus 2 root i1 root i2. So this can be written as root i1 minus root i2 का square. So this is how you can remember formulas. उसके बाद है YDAC experiment. In YDAC experiment we took two slits. ठीक है, distance between two slit was d, and then there was this screen. ठीक है. Then in normal YDAC setup, if you see, then this point O is at equal distance from the both slits, and that is why at O phase difference or path difference is equal to what? 0. And here you get central maxima. यहाँ आपको क्या मिलता है? Central maxima. When we will get maxima again, let's say at this point we get maxima. So light coming from this slit and light coming from this slit will have a phase difference of this much. This extra second light is traveling. And this is termed as d sine theta, where theta is what? Theta is the position vector of this point P from the center of slit. So this is this theta. Okay? And if this is equal to n lambda, you will be getting maxima. And if this is equal to 2n plus 1 lambda by 2, you will be getting minima. ठीक है. Now there is another approximation जिसको आपको याद रखना है. An approximation is that here the distance of a screen, this is the screen on which you are getting interference pattern, and this is the slit separation line, right? If distance between these two is capital D, this distance I have already told you this is small d, and if small d is far less than capital D, everywhere theta will be small, very small. And when theta is small, we write sine theta is equal to theta, and also tan theta is equal to theta. So why I'm telling you this is very important from the point of view of using formula. Let's say at point P, we are getting maxima. Okay? So position vector of point P with respect to this will be at an angle theta. And here two lights reaching, one light from this slit, another light from this slit, will have a path difference of this, as I told you now. So this is d sine theta, and this is equal to, for maxima, n lambda. Now, if d is far, far less than capital D, you can say this is d theta, because sine theta can be written as theta. So this is equal to n lambda. Theta is equal to n lambda by d. अब तुमसे क्वेश्चन ये पूछता है, व्हाट इज द एंगुलर पोजीशन? रिमेंबर, व्हाट इज द एंगुलर पोजीशन ऑफ फर्स्ट मैक्सिमा? तो एंगुलर पोजीशन ऑफ फर्स्ट मैक्सिमा क्या हो जाएगा? एन का वैल्यू 1 रखोगे आप, लैम्डा बाई स्मॉल डी. व्हाट इज द एंगुलर पोजीशन ऑफ second maxima? 2 lambda by d. Third maxima, 3 lambda by d. You may be asked, what is the separation? I mean, or what is the position of first maxima from O? यानी कि तुमसे ये वाला डिस्टेंस पूछ रहा है, ये वाला डिस्टेंस. हाउ यू विल गो अराउंड दिस? सो इसके अराउंड जाने का आइडिया ये है, जस्ट नाउ आई टोल्ड यू, इफ थीटा इज स्मॉल, sin theta can be equated to theta, tan theta can be equated to theta. It means tan theta will be equal to sin theta when theta is small, right? We can take them equal. So in that case, when you're saying, let's say P is fifth maxima, ठीक है, मैंने माना कि P fifth maxima, and I have to calculate the position of fifth maxima from here. What I will do here? So fifth maxima का मतलब d sin theta. This is the basic formula. D sin theta is 5 lambda. And sin theta here can be written as tan theta. It is 5 lambda. And tan theta will be equal to this y by this d. ठीक है? So tan theta को आप क्या लिखोगे? You will be writing as y by d equal to 5 lambda. Now you can easily calculate y, right? So that is equal to 5 lambda d by d. ठीक है? This lambda d by d is also fringe separation, if you have learned. So distance of fifth maxima from the central position is going to be equal to what? It is going to be equal to 5 into lambda d by d. ठीक है? So this is how you can deal with angles also. You should keeping this thing in your mind. उसके बाद तुमसे पूछ सकता है, what is the angular separation of central maxima? So how you go around this? Central maxima means ये point, और central maxima का light कहाँ तक spreaded होगा? Up to the point you get first minima. So let's say here there is first minima and here there is first minima. So if this is the angle of first minima, then also first minima will be on the other side of the screen. Then this angle will be also theta, because both are the first minima. So if this is first minima, this is first minima. In this region, there will be what? You can talk about the angular width of what? Central maxima. Okay. So if you talk about the angular width of central maxima, then you can write here again d sin theta is equal to first minima you will get for lambda by 2. Okay. So d theta is equal to lambda by 2. Theta is equal to lambda by 2d. Okay. So this theta is lambda by 2d. This will be also lambda by 2d. So overall this will become lambda by a. Sorry, lambda by d. This is the d. Now in diffraction, I have told you what happens in diffraction. We have single slit and light will diffract. Diffraction means bending of light. When diffraction happens? When the size of slit is comparable with the wavelength of light. In diffraction also we get maxima and minima. What is the position of maxima and minima? So for maxima here we write a sin theta is equal to 2n plus 1 lambda by 2. Opposite हो जाता है, ठीक है? So in case of diffraction, I am dealing with diffraction here. This is the condition of what? This is the condition of maxima in diffraction. And what is the condition of minima? A sin theta is equal to n lambda, where n will start from 1, 2, 3. Here n का value 0 नहीं हो सकता, and here n will start from 0. ठीक है. Here also you can calculate angular position of everything. Here also width of central maxima, if you will calculate, you will be getting lambda by a here. And if you talk about one more thing, here maxima doesn't have same intensity starting from central maxima to the other maxima. As we go up, intensity of maxima decreases. But in interference, intensity of maxima throughout the screen is same. ठीक है. Now let's solve the questions. अब आप क्वेश्चन करो, it will be helpful. Take your time, do it. Do it, I'm here only. How many of you did it? Okay, I got two answers. Both are incorrect. फ्रिंज सेपरेशन का फॉर्मूला क्या होता है? Distance between two fringes, that is indicated by beta, and that is your lambda d by d. ठीक है. So two slits in Young's double slit experiment are 1.5 millimeter apart. So small d ka value is given 1.5 millimeter, and the screen is placed at a distance of 1 meter. This is 1 meter. If the wavelength of light used is this, then the fringe separation is what? So it's simply you need to put in the formula. Come on, do it. Lambda 600 यानी कि 6 into 10 to the power minus 7 d1. Small d is 15 into 10 to the power minus 4. So this is 6 by 15 into 10 to the power minus 3. 110 I will write here, 110 here. 15 से 64 times चला जाएगा. So 4 into 10 to the power minus 4 meter. What problem you faced in this? You were not aware of the formula? You just needed to put in the formula beta. Beta क्या होता है? अगर कंफ्यूज कर रहे हो तो मैं तुम्हें एक्सप्लेन कर दूं. YDSC एक्सपेरिमेंट देख लो ऐसा. Let's say here there is first maxima, and let's say here there is second maxima. So fringe width is separation between the fringes. Done it? So either separation between two maximas, two minimas, you calculate here this distance. What it will be? Distance of first maxima, y1 कितना होगा बताओ. अभी भी मैंने बताया y1 by d can be will be equal to how much? This is tan theta, and अभी मैंने तुम लोगों को बताया ना सॉल्व करने के लिए. लेट मी डू इट फॉर यू अगेन. प्लीज रिमेंबर दिस थिंग कि इसका मतलब क्या होता है. डी साइन थीटा फर्स्ट मैक्सिमा के लिए क्या लिखोगे? एन 1 लैम्डा. ठीक है, फर्स्ट मैक्सिमा के लिए. एंड साइन थीटा कैन बी रिटन एज tan थीटा. सो दिस इज लैम्डा, और यहाँ पे देखो tan थीटा लिख सकते हैं क्योंकि दिस इज 1 मीटर एंड दिस इज 1.5 millimeter. देयर इज capital D is 10 to the power 4 times greater. So it's far greater. We can write like this. Tan theta can be written as y by d. So this is lambda. Position of first maxima. First maxima का position क्या मिला? Lambda d by d. Similarly second maxima का position क्या मिलेगा? 2 lambda d by d. ठीक है. और यहां से अगर फ्रिंज सेपरेशन निकालते हो तो फर्स्ट इज एट अ डिस्टेंस ऑफ y1, सेकंड इज एट अ डिस्टेंस ऑफ y2. y2 minus y1 if you will do, you will get how much? Lambda d by d. So this is called your what? This is called your fringe separation. This is called your what? Fringe separation. Then इसी तरह से तुम मिनिमा के लिए निकाल सकते हो. So first minima you will be getting where? Lambda by 2 के लिए. So d y by d will be equal to lambda by 2. So y will be equal to how much? Lambda d by 2d. Second minima will be where? 2 lambda d by I mean नहीं 2 नहीं होगा. Second कब होगा? When phase difference will be 3 lambda by 2. So this is 3 lambda d by 2d. When you are going to multiply this to y2 minus y1, you will be getting 2 lambda d by 2d. So this is lambda d by d. Same as before we are getting, right? So fringe separation, distance between two maxima, yeah, distance between two minima will be equal to how much? Lambda d by d. And distance between one maxima and another minima will be equal to lambda d by 2d. अगर आप देखो फर्स्ट मिनिमा का डिस्टेंस कितना है? लैम्डा डी बाई 2d. फर्स्ट मैक्सिमा का डिस्टेंस क्या है? लैम्डा डी बाई डी. दोनों को सब्सट्रैक्ट करोगे, सॉरी ये वाला दोनों को सब्सट्रैक्ट करोगे, व्हाट यू विल बी गेटिंग? लैम्डा डी बाई 2d. सो सेपरेशन बिटवीन टू मैक्सिमा या टू मिनिमा इज लैम्डा डी बाई डी. सेपरेशन बिटवीन मैक्सिमा एंड मिनिमा इज लैम्डा डी बाई 2d. नाउ डू दिस क्वेश्चन and let me know your answers. You just need to check the phase. Yes, everyone getting the answer? Okay, I got two correct answers. Very good. Others, please. Three correct answers. Very good. चलो ठीक है. Now I will end the poll so that I can discuss. देखो, what's the question is? Question is that interference pattern can be observed due to superposition of which following waves? So when we get to see interference pattern only for coherent sources, only for coherent sources. What is the meaning of coherent sources? Sources having same frequency. ठीक है, जिनकी frequency क्या हो? Same हो. ठीक है. So just see here for the first wave, what is the frequency? A is sine omega. Here angular frequency is omega. So frequency omega and frequency is related as 2 pi f. So here f is 2 pi by omega in first case. What is frequency in the second case? Frequency in the second case is equal to 2 pi by 2 omega. What is the frequency in the third case? A sine omega t minus pi. So it's omega. So it is 2 pi by omega. What is frequency in the fourth case? This is 2 pi by 3 omega. In which case frequency is same? You just check. So here it is 2 pi by omega and here also it is 2 pi by omega. So for A and C, so answer will be A and C. That is option C. Done. इन दो waves को superimpose करके you will be getting what? You will be getting interference pattern. Interference pattern meaning you will be getting maxima, minima, maxima, minima. That pattern you will get. But if you mix two incoherent sources having different frequency, you won't get pattern. You get uniform illumination on the screen. What is the meaning of this uniform illumination? इसका क्या meaning होता है? तो देखो, जैसे when you get interference pattern, then maxima has an intensity of 4 I naught. If from here amplitude is A and from here amplitude is A, both are sharing the same amplitude, then maxima will have intensity of 4 I naught, minima 0, again 4 I naught, again what you will get? 0. So you are getting a pattern of intensities, right? And hence pattern 4 I naught 0, 4 I naught 0. So you will get light, dark, light, dark, light, dark. So yep, a pattern you're getting. But if you're using incoherent sources, here both were sharing the same frequency. If you are using lights of two different frequencies, let's say this is f1, this is f2, then on a screen, you won't be getting interference pattern. You will get uniform illumination. What does it mean? It has a simple meaning. If intensity of light here is I1, intensity of light here is I2, then at each point on the screen, on each point on the screen, you will be getting what? You will be getting intensity I1 plus I2 everywhere. So same intensity of light you will be getting. So uniform illumination. Here it's not uniform. There is a pattern. Done. So this is the difference. Sorry. Now do this. सभी लोग सॉल्व करो. Yes. Anyone who got the answer? Very good. Ethan, that's correct. Very good. Okay, I got one correct answer, one wrong answer. Okay, two correct answers. Very good. Come on, more people. Let me know your answers. Chalo, theek hai, I'm ending the poll. I will let you learn what are the things we need to remember. So this question is from a Malus' law. Malus' law says that if you have a Polaroid, if you have Polaroid of any shape, let's say like this, and you are allowing polarized light fall on it. Always remember, Malus' law we use for already polarized light to polarize it further, right? So if polarized light is falling on the Polaroid, let's say its intensity as I naught, and the intensity that this, I mean, sorry, angle that this light is making with the pass axis of Polaroid is theta, okay? Then intensity that will pass through this Polaroid, let's say I, will be equal to I naught cos square theta. So Malus' law this is, and it is applicable for polarized light. Now come back to the question. A beam of polarized light of intensity unpolarized light. Read here carefully. Beam of unpolarized light of intensity I naught here is uh, uh, is passing through a Polaroid A, then through another B, then through C, and finally through B. The intensity of emerging light through the final one will be what? This is the question, right? So whenever you pass unpolarized light through Polaroid, how we calculate the intensity? We basically take average of this. We don't put in any angle. We simply take average of the intensity. So here average will be how much? I naught ka average I naught. Cos square ka average kya hota hai? Half. So this will become 2. I naught by 2. So if you allow unpolarized light to pass through Polaroid, intensity of light that you will be getting is I naught by 2. And then light that is coming out of Polaroid is now polarized. Okay? So पहले Polaroid के through what happened? You passed here unpolarized light of intensity I naught. So whatever light will come out will be polarized. Okay? It was unpolarized and its intensity will be half of the incident one, I naught by 2. So now this I1 is a polarized light having intensity I naught by 2. It is allowed to fall on the Polaroid B. So now we will use Malus' law for second Polaroid B, and intensity of light coming out through B, let's say it is I2, then I2 can be written as I1 cos square theta. I1 is how much? I naught by 2. Theta is how much? 60 degrees. So cos square 60. So this will give you how much? I naught by 2 into 1 by 4. So this is I naught by 8. Now this I2 intensity of light is falling or it's getting allowed to pass through Polaroid C. What will be the intensity of light passing through C? That is the final answer. So let's say it is I3. So I3 को आप क्या लिखोगे? It will be I2 cos square theta. And here I2 is how much? I naught by 8. Theta is how much? 45 degree. Cos 45 is 1 by root 2. So 1 by root 2 का square. So this is I naught by 16. So correct answer is your 1. ठीक है? चलो. Now do this question. Everyone. This question is also given in your NCERT inbox. है ना? This is a very common question. Okay. I got two correct answers. One is wrong. Okay. Let me end the poll now and let me explain this to you. What happens when we are using white light? White light ka meaning what? It will have several wavelengths. So if we talk about central maxima, if you talk about central maxima, then no matter what is the wavelength of light, when all light will travel here from both the slates, they will cover same distance. ठीक है? And so path difference is 0 here. So for all light, central maxima will be what? This center point will be the maximum. I mean, for blue light, this O point is maxima. For green light, it is point of maxima. For blue light, it is point of maxima. For red, orange, violet, for every light. And if every color of light is present at O, maxima means that light is present, right? So every light is present at that point. It means here the color that you will be getting is white itself because all color are present there. So central maxima will be what? White. So this is going to be white. What about the other, I mean, will all other maxima be white or we will get certain colors as we will move away from the central maxima on the both side of a screen? So if you consider the position of first minima, let's talk about first minima. क्योंकि मिनिमा के लिए पाथ डिफरेंस लैम्डा बाय 2 होता है, मैक्सिमा के लिए लैम्डा होता है. सो फर्स्ट वी विल गेट फर्स्ट मिनिमा, नॉट फर्स्ट मैक्सिमा. सो लेट्स चेक फॉर फर्स्ट मिनिमा. सो मिनिमा के लिए अगर आप चेक करोगे, लेट्स से हियर देयर इज मिनिमा. सो फॉर मिनिमा वी नो दैट दिस थीटा डी साइन थीटा शुड बी इक्वल टू लैम्डा बाय 2 फर्स्ट मिनिमा के लिए. And this d sine theta is having certain distance. Let's say this is x. And for any wavelength of light to be minima here, this lambda by 2 should be equal to x. Okay. So first, which color of light will get equated to x? Whichever will share the small wavelength. समझ रहे हो मेरी बात का मतलब? See, यहाँ से light गया, यहाँ से गया. This path difference is this much. So difference is this much, this x. So this x will first become equal to which lambda by 2? For which color it will first become equal to lambda by 2? So if you talk about Vibgyor, then you already know red light has the longer wavelength. And long wavelength means X will not first equate to the longer wavelength by 2. It will first get equated to what? The smallest wavelength ka value, right? So X will be first equal to lambda by 2. डन है, क्योंकि अगर तुम फर्स्ट मिनिमा निकालने जाओ ना, तो फर्स्ट मिनिमा जो है वो वायलेट के लिए अगर यहाँ हो रहा है, तो रेड के लिए कहीं यहाँ होगा, क्योंकि फॉर रेड लाइट सेपरेशन पाथ डिफरेंस शुड बी मोर ग्रेटर, बिकॉज फॉर रेड लाइट लैम्डा आर बाई 2 जब आप करोगे तो दिस वैल्यू विल बी लार्जर, एक्स हैज टू बी लार्जर, and if x is larger it means you will get first minimum of red light later than first minimum of violet light. तो मेरे कहने का मतलब ये है कि सेंट्रल मैक्सिमा के बाद पहला मिनिमा किसका होगा? वायलेट लाइट का होगा. एंड अगर जहां पे वायलेट लाइट का मिनिमा है, यानी कि वायलेट लाइट इज नॉट प्रेजेंट, smaller wavelength light is not present, it means longer wavelength light will be present, right? So it will look something reddish. Done it? So the central bright fringe will be white, surrounded by few colored fringes. And if somebody talks about what will be the color of fringe, so nearest to white fringe, there will be reddish color lights. Okay? So that is thing. Which answer will be correct? There will be central dark fringe? No. Interference pattern will disappear? No. There will be central bright white fringe? Yes. Surrounded by few colored fringes? Yes. All bright fringes will be of equal length? No, because there can be red bright fringe, yellow bright fringe, and for every bright fringe, separation will be lambda d by d. Since lambda is different for all colors of light, fringe width will be different. So correct answer will be C. Okay. Now let's do this question. It is from the Brewster's angle. Do it and let me know. Just remember the diagram in Brewster's angle, calculation, derivation, or understanding, whatever diagram you have drawn. Just bring that into your mind. ठीक है? Okay, I got one answer and that is not correct. Okay, two answers, both wrong. Let me take you to the thing. What is Brewster's angle? So we have learned that we can polarize light through refraction and scattering. है ना? We have learned by two methods we can do. By refraction and what? Scattering. So this Brewster's angle is basically the angle that we get when we are trying to polarize light through the method of refraction. So there was this interface. Let's say this is having refractive index N1. This is having refractive index N2. This is N1 is basically air most of the time. So what is happening? We are allowing a light coming from the sun. So this is natural light coming. And when you talk about natural, sorry, it is quite looking curved that I cannot draw, right? Oh God. This is more blunder. ठीक है? Okay, done it. So this light is the natural light coming from the sun directly. So it will have both vibrations present. Both vibration means vibration perpendicular to the plane and vibration in the plane. So both components will be present here, components of electric field vector. So both are present. And for a certain angle of incidence that we call I, what we get is we get refracted light like this, and also reflected light we will be getting. So for a particular angle of incidence, we get polarization in the reflected light. So here only these components are present. Vibration in the plane of this diagram got mostly absorbed, and this refracted light will have this thing, and also somewhere this one, like this. So I mean, what happens when you allow a light to be incident on that? How this reflected light is generated? It is generated by vibration of atoms over here. So during that vibration, only perpendicular electric field component is getting generated, and in refracted light, you will be mostly getting this wala vibration, arrow wala vibration. This dotted vibration will be less. So this light is partially polarized. Okay, this is partially polarized because arrows are more present, dot are very less, very uncommon. So this is partially polarized. Here only one vibration is present, and that is why this is called what? Completely polarized. And this happens for a particular angle of incidence, I, that is called Brewster's angle, IB. And in that case, this angle is your 90 degree. That is, angle between reflected light and refracted light is how much? 90 degree. And here, if you will calculate things, you will get tan IB is equal to mu. Mu is what? Refractive index of second media with respect to 1. So this is N2 by M. Okay, so this is Brewster's concept. Now, what will be the answer? ओके कुछ लोगों ने मुझे सही आंसर दिया था एक्चुअली. अच्छा, कुछ लोगों ने मुझे डी बोला है ना. यस, 1D आई हैव गॉट, दैट्स करेक्ट. आई हैव रिटन हियर आंसर एफ डी व्हिच इज इनकरेक्ट. आंसर विल बी डी. चलो, नाउ डू दिस क्वेश्चन एंड लेट मी नो योर आंसर्स. Take your time, do it, think around it. Anyone? Okay, very good. I got one correct answer. That's great. For a green light, we are getting this case, right? And you already know how refractive index depends on the wavelength. So, refractive index is inversely proportional to 1 by lambda ka square. This is called Cauchy's formula also. Done it? So this is truth. And if you solve this question, I mean, for green light, we are getting a critical angle situation, right? So for green light, this angle is the critical angle. Done it? And we know that critical angle is equal to how much? 1 by mu. We know this thing, right? Where mu is what? Reflective index of glass with respect to air. Here, right? So for any, I mean, here it is, which set of color will come out? So which set of color will come out, which will not get totally internally reflected? Done it? Which light will not get totally internally reflected? Or let's think about which light will get totally internally reflected. The light for which this angle of incidence I this I is greater than IC, that light will get internally reflected. So for green, this is IC. For which other colors, this I value will be what? Greater than IC or less than IC? Let's talk about, because for different colors, IC value will be different. For green, this is IC, but for others colors, let's check. Okay? So let's say this value is I. So for any light to get internally reflected, I should be greater than IC. Sine का sine function दोनों side ले लो. So sine I will be greater than sine IC. And you already know sine IC is equal to what? 1 by mu. Okay? And 1 by mu is what? Mu is directly proportional to 1 by lambda ka square. 1 by mu will be directly proportional to lambda ka square. 1 by mu can be written as some constant k into lambda ka square. So here what I am going to do is sine I is greater than k lambda ka square. Okay? Now let's think about green thing. Green के लिए हमें क्या आया? This I is equal to actually IC and this is equal to K lambda green का square. तो basically sin IC का value तुम्हारा क्या है? K lambda G का square. And for which case this IC will be greater than K lambda का square. So what I'm telling is this I is fixed, right? So this I is IC for green light, and that sine IC is equal to how much? This. So here sine I can be written as K lambda G ka square, and that is equal to K lambda ka square. So total internal reflection will happen for wavelengths that is less than green light. For lambda square, less than green one. So am I getting opposite? It feels like. Okay, let me check. Which light should be, which set of color will come out bola hai na? Okay. So what I'm here trying to calculate is which color will get totally internally reflected. So which color will get totally internally reflected? Lambda, whatever lambda is less than lambda G. So which lambda is less than lambda G, that will get totally internally reflected. Done it. So which one will get totally internally reflected? Blue light, violet light, whichever wavelength is less than green light. Green light से बड़ा wavelength किसका होगा? Yellow, orange, red. So that will come out. Done it. So which one will come out? A. Which one will get totally internally reflected? So that will be basically blue, violet, and all. Done. So how you will be solving such sort of question? Let me erase everything and tell you. This angle of incidence should be greater than critical angle for total internal reflection. And that is why I said sine I should be greater than equal to sine IC. And sine IC is equal to how much? 1 by u square. And 1 by u square is equal to k lambda ka square. So sine I should be greater than k lambda ka square. Okay? And here it is given that this I is basically equal to IC for green light. So if you put the value of here sine I is equal to IC for green light. So for green light, this will be equal to K lambda green ka square. So which light will get totally internally reflected? Whose wavelength will follow this relation? That is, whose wavelength will be less than green light. That will come here, and which will go out जिसका wavelength green से बड़ा होगा. That is yellow, orange, red. So option A. Now do this question and let me know your answer. Yes, you just have to read the statements. ठीक है? Read it and let me know. Okay, I got two answers, three answers, two is correct, one wrong. What will be the answer? If you see here carefully, Deepu. Yes, that has to be correct. Yes. So statement क्या है देखो ध्यान से पढ़ लो. The screen is moved away from the plane of slates. That is D is increasing. ठीक है. Angular separation of fringes remains constant. Just now I told you angular separation of linear separation fringe का बीटा होता है lambda d by d. Whenever you have to calculate angular separation, divide linear separation by capital D. क्योंकि देखो अगर ध्यान से तुम्हें याद हो ये थीटा बोला था मैंने, ये वाई बोला था, ये बोला था कैपिटल डी. ठीक है. सो इफ यू टॉक अबाउट angular separation of fringes, let's say one fringe is here, another is here. So for one, tan theta will be equal to how much? Theta 1 y by d, है ना? And where will be the another नहीं, yes. So first fringe is at an angle of theta 1 equal to y by d, and another fringe will be at a separation of how much? That is equal to this y dash by d. And what will be the angular separation? Theta 1 minus theta 2. So this is basically your y dash minus y by d. ठीक है. एंड y dash minus y क्या होगा? लैम्डा d by d. ऐसे ही करोगे ना. आई मीन एक होगा तुम्हारा n1 lambda d by d, दूसरा होगा n2 lambda d by d. And if n1 and n2 are continuous, then if n1 is 3, then n1 will be 4. So if you will subtract it, you will get lambda d by d into d. So angular separation is how much? Lambda by small d. Simple. So whenever you have to calculate angular separation, what you will do? Linear separation is lambda d by d. Simply do one thing: divide this whole thing with capital D, right? So then you will get angular separation. So angular separation is how much? Sorry, this is lambda, yeah. This is lambda. So that is lambda by D. ठीक है? Done it? So this is the angular separation. So when you are changing capital D, angular separation, lambda by small d is not going to change. Second statement, if the monochromatic source is replaced by another monochromatic source of larger wavelength, angular separation of fringes decreases. So angular separation क्या है तुम्हारा? Directly proportional to lambda. If lambda is increasing, theta will also increase. So here it is said it is decreasing. That is incorrect. So correct option will be one is true, two is false. So option B. ठीक है? चलो. Now do this question and let me know what you're getting. Even with the answer. Okay, let me end the poll and discuss this with you क्योंकि आप लोगों को difficulty हो रही है maybe. In a Young's double slit experiment, a student observes 8 fringes in a certain segment of screen. So there is a screen, and what is happening? We are getting 8 fringes for which wavelength? 600 nanometer. So if you are getting 8 fringes in a certain region, Sasank, not correct. Maybe you're not taking. Okay, let's check the solution. So यहाँ पे ये screen है, and let's say this is O. In one space, let's say in this space, 600 nanometer wavelength is getting 8 number of fringes. ठीक है? So for one fringe, it will occupy how much angle? If you talk about first maxima, then d sine theta is equal. Fringe means it's talking about maxima, okay? So d sine theta n lambda. For one maxima, we will occupy angle of lambda by d. ठीक है? So for 8 fringes, how much angle we are going to occupy? If in this region 8 fringes are there, it means this angle theta dash is equal to 8 lambda by d. ठीक है? And now what is said? If the wavelength of light is changed to this one, then number of fringes. So let's say for 400 nanometer in this same region, how many number of fringes we will get? Angle will remain same, right? So again, theta dash will be here equal to n lambda dash by d. Okay? We need to equate these two because both angles are same, because both are forming different number of fringes in the same space. So 8 lambda by d will be equal to n lambda dash by d. This will get cancelled. 8 into 600 is equal to n into lambda dash, which is equal to 400. So if you will cut it, you will get here this n equal to 12. So how many number of fringes we are going to get in that space? 12. Okay. This is how we can proceed. Now do this question. After this question, we will close. Don't worry. एंगुलर विथ ऑफ फर्स्ट मिनिमा पूछ रहा है, ठीक है? Okay, so what is the angular width of first minima? First minima, let's say we are obtaining here. So from center, it is here. So this is the angular width of first minima. Let's say this is y. And for first minima, we know that d sine theta is equal to lambda by 2. ठीक है? Theta is small here, 0.2 degree. So sin theta की जगह theta लिख सकते हैं और sin theta को tan theta लिख सकते हैं. लैम्डा बाई 2. इफ यू इफ और यहाँ पे लैम्डा बाई 2 करने की जरूरत नहीं है क्योंकि हमसे बोला गया है एंगुलर विथ इज गिवन. सो बेसिकली साइन थीटा को थीटा लिख सकते हो, डी थीटा इज लैम्डा बाई 2, एंगुलर विथ इज लैम्डा बाई 2d if you take angle as a small, right? So this is this. Now if you are replacing this wavelength, I mean, if you are immersing the whole apparatus in a media whose refractive index is this, then what will change here? Angular separation is what? Lambda by 2d. 2 is a constant. D is separation between slit. It is not going to change because you are changing the media. With media, what will change? Wavelength. Wavelength will become lambda by mu. So if lambda by 2d is equal to 0.2 degree, then this will become this. I mean, here lambda will become what? Lambda by mu. So by mu. And by mu, if you will do, then 0.2 by 4 into 3. Okay. So this is going to be how much? This is your mu water is 4 by 3. Will it become lambda by mu or what? Because velocity by lambda is your wavelength. Okay. Sorry, frequency. So when the media changes, what happens? Frequency remains constant. And okay, we need to check with 8 seconds. How we can do this? Yes, Asam, that is correct. But I got stuck somewhere. I don't know where. So lambda ko we can write. I mean, it will become lambda by mu, and lambda by mu अगर आप करते हो, so this will be 4, 3, 2d, right? Lambda by 2d is given, that is 0.2 degree. So 3 by 4 into 2 by 10, and this is going to be 2. So this is going to be, yes, 1.5 by 10. So this is going to be 0.15 degree. So that was correct actually. Okay. So what will happening whenever you immerse whole YDSC apparatus into different media, simply wavelength will get changed by wavelength by mu. Always remember this thing. Okay. So this was all for the today's class. अगर किसी को कोई doubt है, let me know. Otherwise, we will be meeting tomorrow. Okay, tomorrow will be the last class, so we will do some questions, and you people will keep on doing questions. Stay relaxed, but don't worry, and keep on practicing more number of questions. Give your 100%. Okay, and for that, stay healthy, happy, and keep enjoying also. But use your time wisely. Thank you, everyone. Bye. Take care.